Everyone, my name is Kokil Bansal. I am a senior project professional working at SCS Engineers, and I work out of the Miami office. And today I'll be talking to you about carbon sequestration. So right now we know that global warming is happening, and the reason is that there's a huge amount of greenhouse gases which are in the atmosphere. Now, greenhouse gases are not really a bad thing because they trap the sun's heat and make the life at Earth viable. However, in the Kyoto Protocol that happened, they listed that there are 7 greenhouse gases, out of which carbon dioxide and methane are in excess. So, carbon dioxide, the way it is released into the atmosphere, is when we breathe, when through respiration, when there's a decay of microorganisms, and through industrial emissions. And the sinks for carbon dioxide, how it is removed, is basically by plants when they photosynthesize. So carbon sequestration is the process of capturing, securing, and storing the carbon dioxide from the atmosphere and stabilize it so that it does not get released back and cause the atmosphere to warm. So there are 2 main types of carbon sequestration. One is the geologic and one is the biologic. And I will talk to you a little bit more about these two in the next coming slides. So biologic carbon sequestration is what happens naturally around when plants, as I mentioned, photosynthesize. And then they store that carbon dioxide in their bark, their roots, their tissues. Another sink of carbon dioxide are the oceans and wetlands. In fact, oceans store the largest percentage of carbon dioxide on our planet. And the third is in the soil, when microorganisms and fungi, they create these chains that store and link the carbon dioxide. And then you have the man-made way, which is the geologic carbon sequestration. So human beings, we capture the carbon dioxide, we transport it, and then we inject it deep within the geologic formations below the Earth's surface. And the way you store that carbon dioxide you can do it in several forms. One of them is bio oil, which is sort of like a tar-like substance, which secures the carbon dioxide. And the second is as a supercritical fluid. So supercritical carbon dioxide is a very unique way in which carbon dioxide behaves. So it has the properties of a liquid while being a gas. And that happens at this critical temperature and pressure. So think of it this way. You have a room which is 100% carbon dioxide. And now you want to store that carbon dioxide in the geologic form. So as you start injecting, the temperature and pressure increases. Once it hits that critical threshold, the volume of that gas starts decreasing, so much so that this whole room, which was filled with carbon dioxide, is now the size of a pebble. So the potential to store that carbon dioxide in the geologic formations is pretty huge when we store it as a supercritical fluid. And you can store it in a lot of different geologic formations. One of them is in the deep aquifers. So the water and wastewater treatment industry, they have been injecting using the deep injection wells, the water, the contaminated water or the refuse in these aquifers. The same aquifers have the potential to store carbon dioxide. Another is that the oil and gas industry, they have extracted oil and now those reservoirs are depleted. However, the geologic porosity still works, which can store the carbon dioxide. Similarly, the same is for coal mines. And within the United States, it has a lot of potential. So on this figure, you can see orange and brown basins where studies have been conducted and carbon sequestration have been found viable in those areas. So this covers a lot of area within the United States where geologic carbon sequestration is possible. And currently, the market is very, very hot when it comes to carbon sequestration. A lot of companies have sustainability goals. Even the government has some incentives that they are giving industries to look into carbon sequestration. Some of them are mentioned on the slide here who are participating in carbon sequestration. So another thing that I want to mention here is that there is something called voluntary carbon credits, in which a company buys and sell credits. So they are basically called verified emission reduction criteria, where a company, they invest in the carbon sequestration technology, and they can show that they are carbon negative or carbon neutral. So what happens is the companies which invest, let's say, directly in the geologic carbon sequestration, they now have a negative, and they sell those extra credits to the companies which want to offset their own emissions, and they can become carbon neutral essentially. On this slide, I have a portfolio of Microsoft. So they have invested in a lot of different kinds of carbon, one in biologic and geologic. The forestry is the biologic. And even though the contracted volume there is in the thousands, 100,000s, if you look at the duration that the carbon dioxide is being removed, is about 100 years. Compared to the one with the bioenergy, even though the contracted volume is lower, it is removed for 10,000 years. So the important thing here is when you invest in geologic carbon sequestration, you're essentially removing the carbon dioxide for a really long period of time. Because when biologic carbon sequestration, after decomposition, as I mentioned, the carbon dioxide is released back into the atmosphere. So that's just something to consider in the future. Some of the benefits of geologic carbon sequestration, as I mentioned, it provides our clients with a long-term assets. They are able to sell those credits at a higher rate compared to biologic, and it acts as a permanent storage while being protective of the environment. So when it comes to the permitting aspect, SCS currently has a few projects which are in the permitting process. So the ones that of these 6 permits that you see that is for carbon sequestration is class 6. So the class 1 to 5 are the typical injection wells that are being used across the United States, and the class 6 is specifically for carbon sequestration. And the permitting process is actually pretty long. It can take anywhere from 4 to 8 months. It has 12 main steps, and you need a multidisciplinary team of around 12 to 15 people to make a project of this level viable. And there are a lot of different factors that come into play when you are creating a project of this size. Some of the projects that SCS has done are shown represented by the star. We have done feasibility studies across the states. And these projects right now, the one in California and Louisiana are in the permitting process. And the one in Oklahoma is actually, there's a pilot program going on right now. So there is a lot of expertise at SCS Engineers. We have Stephanie Hill, Monty Markey, who are experts in underground deep injection well and now carbon sequestration as well. So just to summarize, carbon sequestration is a very up and coming technology which will help our fight against climate change. And we have, as I said, we have a lot of in-house expertise that SCS provides. And please contact us if you have any questions, and thank you very much for your time.